The Bronsted-Lowry theory of acids and bases classifies acids and bases based on what they do, not what they are. An acid then is a proton or H+ donor. For example, HCl is an acid in terms of the Bronsted-Lowry theory because HCl donates a proton to the water. This results in the products of a hydronium ion and a chloride ion. A base in terms of Bronsted-Lowry theory is a proton acceptor. This can explain our observation of ammonia being a base. It is considered to be a weak base because it partially ionizes water to produce hydroxide ions. When ammonia reacts with water, it produces an ammonium ion and hydroxide. The proton gets donated from the water to the ammonia. So ammonia is accepting a proton, making it a base in terms of the Bronsted-Lowry theory. In each acid-base reaction, according to the Bronsted-Lowry theory, there is an acid and there is a base. For example, if we go back to our hydrochloric acid reacting with water, a proton is being donated from our HCl to our water. That means that our HCl is acting as an acid and our water is acting as a base. Furthermore, if we look at the products, the chloride ion is the result of the HCl losing its proton. And since the HCl is an acid, we would say the chloride ion is its conjugate base, because now chloride ion is able to accept a proton. Same with water. Water is acting as a base in this reaction. We would say that the H3O+ ion is its conjugate acid, because if this reaction were to happen in reverse, it would donate a proton. In the reaction of ammonia with water, the proton's being donated from the water to the ammonia. The water then is our acid, ammonia is our base. That means that the OH- is our conjugate base and NH4+ is our conjugate acid. Water is a special molecule according to the Bronsted-Lowry theory because it can act as both an acid or a base depending on the situation. We often use the terms for water and classify it as either amphiprotic, meaning that it can donate or accept protons, or we use amphoteric, meaning that it can act as either an acid or a base. Another example of an amphiprotic or amphoteric ion is the bicarbonate ion, HCO3-. When we react HCO3- with hydrochloric acid, the HCO3- acts as a Bronsted-Lowry base. If we react it with ammonia, which is a weak base, the bicarbonate ion now acts as an acid.